Finishing up lesson 5.1, which dealt with rectangle approximation methods to find area underneath a curve, we're going to look at a tabular problem. And for example 2, it says, given the table, estimate the distance traveled over a 25-second interval. Well, if we were to make a graph, by the way, you don't have to make a graph here, but I do want to at least comment as to what that would look like. You would have velocity right here. This would be in feet per second. And let's say it looks as we are going from 25 up to 47. Maybe go by 10. Here's 20. Here's 30. Here's 40. Up here would be 50. Down here we'd have time in seconds. And it looks like we're going all the way up to 25, so maybe we can go by steps of 5, 10, 15, 20, 25, and we can get a nice sketch going in a hurry. What you're going to notice real quickly is we'll have at 0, we have a height of 25, so we could just approximate that. At 5, we have a height roughly of 31. And by the way, here's something that some teachers do also. You could even make a vertical segment and write 31 up here. You don't have to, but the reason why you can get away with this is we're going to be making rectangles. And that could very well make life a little easier. 35 might be a little bit higher. Maybe slide that over a little bit for 10. And what you're going to be able to do is very quickly create some rectangles. We're going to have at 15, we're at 43, so that's a little bit higher. At 20, we'll be up at 47. That looks like it's the highest we'll ever be. Don't even have to get this perfectly at all. 25, we're up to 46, just a smidge lower. Now the reason why we can get away with drawing these segments is those segments are actually going to be parts of rectangles if you think about it. You're going to notice that our base, our delta t, is always increasing by 5. That's not going to happen for every problem, to be certain. Even if your bases aren't uniform, you could still find the area of all the collective rectangles. But our heights now, for part A, it says using a right rectangle rule. We're going to say, look, on our first interval, it's that, of course, right endpoint that determines the height. Look right here, for our second rectangle going between 5 and 10, it's the 10 that determines the height. Right here, it's the same thing for 15, for 20. And then for finally right here, we're just a smidge lower. Now, this can be helpful for students as they go ahead and try to work this out. I have commented in class, however, about the importance of actually just even making sense as to when you're finding area and when you might just be using tangent line slopes. Just in general, I want to make a comment that if you look at any of these rectangles, the vertical dimension is in feet per second. That's the vertical units. Down below, the x component is seconds. And when you multiply base times height, you'll have feet per second times seconds. That is going to be just in feet. What does that mean? Well, it means that we're finding feet when we find area. By way of comparison, sometimes look in the top right corner here. Sometimes kids are, mixing integral and differential calculus, and sometimes they get a little confused as to, what they need to do to solve a problem. They might wonder if they need to go back to previous chapters and find a secant line slope. Well, that would be feet per second divided by seconds. That's feet per second squared. And that would be finding acceleration. So, here we're seeing the y as to how area of a velocity curve, the area bounded by that velocity curve and the x-axis actually is going to represent, in this case, distance traveled. Well, to find that area, you're going to notice that each of these bases is 5, and you can say 5 times, well, your first height is 31, your next height is 35, your next height, and that's why these numbers can be very helpful. Your next height can be 43, then 47, and then finally 46. I do want to point out that truthfully, you can do this without even having a picture. Here's what I'm talking about. And many kids just jump into doing it this way. They'll say, look, I know that my base would be 5. If I'm dealing with a right endpoint, then I'll have a height of 31, and they'll, be able to get the area of that first rectangle. And then they'll move on to right here into that second interval between 5 and 10, and they'll say, look at the base from 5 to 10, it's just a 5. And they'd put the 5 right here, and they'd say the right endpoint would be determined by the 10, that's 35. And you could continue working that out, and you can very quickly arrive at a rectangle approximation rule or estimate. Do want to point out, when your bases are all the same, and they are the same here, feel free to factor out that base. The reason why is that, yes, we are going to have to do some work to finish this problem up. You could multiply 5 to each of those quantities, all those heights, and add them all together. Or perhaps this is even a quicker way. You could just say, well, you know what, we'll just type in a 5, parentheses, and then say 31 plus 35 plus 43 plus 47 plus 46, close your parenthesis, and you'll get 1010. So, why did I even bother drawing the picture? Well, it's important to show where all of this is coming from. In the future, if you get a tabular problem, feel free to do it directly. Always include units, however. Pay very close attention to units. To wrap up this video, we're not even going to do part B. It's very much the same idea. But as we're taking a look at a homework problem in the book, some students were asking questions about number 2, the very first homework problem that was assigned. And the problem with number 2 is there's this arbitrary function that seems to be drawn, and sad to say, you don't have the exact formula. Because you don't have the exact formula, you cannot do the sum sequence as we did in example 1. The sum sequence, you need to know the expression for f multiplied to x. Likewise, the problem that we just did right here, we don't have the velocity function. We still found an area approximation, but we had to work off of the numbers that we were given. That's more or less what's going to happen with this very first homework problem. You determine your base for every rectangle. I believe it's 2. But I guess what I'm getting at is that when you do, say, a right rectangle approximation, what you're going to have to do is eyeball or estimate what this height is for that right endpoint. You might have to guess a decimal. You might have to get, eyeball to get something like 8.3. And I think for all of the bases, they're the same. So, you can go rectangle by rectangle and just do some of your best guessing. We don't put questions like that on tests, and the AP exam isn't going to do that either. It gets to be way too cumbersome to grade, and you will be more likely given table problems instead. But I just wanted to talk about a problem like that. The majority of what you have for homework is actually going to be a formula for f given, an equation for f. Like you might have f of x's cosine. That's when we'll use our sum sequence. You'll find your beginning x, your ending x. Always put delta x in there, and you should be in good shape. Hope this is helping. We'll definitely pick this up again very, very soon.